I'm Eric Schacht, and I'm with the Ohio State EcoCAR team. I'm the team leader, and what I have behind me is the vehicle that we're converting to a more efficient, better emissions, consumer acceptable powertrain designed by the students here at Ohio State. And we're working to compete with this vehicle against 15 other universities around North America. I'm holding here a 128-pin Woodward controller that the Ohio State team uses to control their engine in both the vehicle as well as in the dyno. In the dyno, we would develop the software and tune and test the engine, and then in the vehicle, we would tune the software in terms of the variations and everything that you would see in the vehicle setting. So I have here a 48-pin Woodward controller. This is what we use for general control for the OSU team, such as driver communication, cooling functions, as well as startup functions of the vehicle. So it handles those general functionalities in order to maintain and improve the efficiency of the vehicle.
I'm Catherine Bovey. I'm a member of Ohio State's EcoCAR team, and I'm standing here inside the test cell with one of our 1.8-liter compressed natural gas engines that Honda donated to us. And although this engine was originally made to run on compressed natural gas, we chose to run on E85 fuel instead, and E85 is just a form of ethanol. Because we're running on an E85, we basically have to rewrite the entire engine controller code to take into account this new fuel, which would usually be a very long process. But with the rapid development tools given to us by Woodward, we're able to really decrease the time it's taking us to calibrate this engine. And since we have two engines, we can easily go inside here in the test cell, change some calibration files on this engine, and run it to make sure everything's working okay before we put it inside the vehicle for the actual competition. And in addition to the rapid development tools that Woodward has given to us, we can also change the starter model they gave us to take into account other devices that we've put on this engine, including an electrically heated catalyst. And this catalyst is able to heat up faster, so we have a better chance at reducing a lot of the emissions produced by a vehicle, like the hydrocarbon, the carbon monoxide, and nitrous oxide emissions that are a common problem into today's vehicles.
My name's Ryan Everett, and I'm part of the EcoCAR engine development team, and we're located in the engine control room right next to the engine dynamometer test cell. And since we're converting a 1.8-liter compressed natural gas Honda engine to run on E85 fuel, we're using the Woodward tools to rewrite our control strategy for the engine in order to better improve our energy consumption and reduce our exhaust gas emissions. We've instrumented our engine to measure useful parameters such as throttle position, intake manifold pressure, and mass airflow into the engine, and we've connected those sensors through the Woodward hardware. And we've used Woodward software in compatibility with Inca to measure these parameters at real time so that we can check to make sure the control software and calibrations that we've completed are doing what we intended them to do.
I'm John Krukenberg, and I develop control systems for the Ohio State EcoCAR team. And this is our hardware in the loop lab, where we can test component interaction and model-based design on our controllers to make sure things act appropriately before we use any real hardware with the systems. Here we're testing the Woodward engine controller that we use in the vehicle and in the dyno, and we've connected components to do fault diagnosis, and here we're showing some throttle control to make sure that things act as they should when we move to the real hardware. One of the big advantages of the Woodward tools is that they interact pretty seamlessly with other industry standard products from ETOS, the MathWorks, and DSpace, so that we can do some testing here with the Woodward ECU on our DSpace hardware in the loop setup, and we could use Woodward tools like MotoTune here to change things in the real system and see how the actual components react.